Okay, number 11, the problem we might have been able to put in the previous section. We're told that the derivative of y is 2 sine x. All right, and the initial condition y of pi is equal to 1. And the question is, which of the following would be a function of y? So we're really just trying to solve for c here. But first we got to take the antiderivative of 2 sine x dx. All right, and the antiderivative of sine we know is negative cosine. So this becomes negative 2 cosine x plus c. This is our y. Now if we plug in pi, we get 1. So y of pi is equal to negative 2 times the cosine of pi plus c. All right, now we got to know our trig chart. The cosine of pi is negative 1, so negative 2 times negative 1 plus c. And we're told y of pi is equal to 1. So this is equal to 1 and this is equal to 1. So we have c plus 2 is equal to 1, so c must be negative 1. And that negative 1 is going to go back here. So we want negative 2 cosine x minus 1, which is d. All right, number 12 is a quick one. We have our function here. We're taking the derivative of the accumulation function. So this is the quick one where we just plug the upper bound in for t. Now we've got to be careful because the upper bound is an inner function. So that means this is a chain rule. All right, so for starters, we plug the 2x in for t. So we have natural log of the quantity 2x cubed plus 1. All right. And we're going to take that whole thing and multiply it by the derivative of 2x, which is 2. Okay. So 2 cubed is 8, so this becomes natural log of 8x cubed plus 1. And notice that's one of our answers because they're going to see whether or not you remembered the 2. That's still there. We can put it at the end or we can put it at the beginning. All right, but we need that 2 because they're going to try and trick you with an answer like B. Oops, I picked the wrong one. I apologize. I went too fast. D is the answer. I lost my 8. That was not good. All right, but we same thing here, except we just got the 2, and so I should have picked D, not C. I apologize for that. All right, 13. Here's the graph of f. We see that g is an accumulation function from 0 to x of f of t. What is the value of g of 5? All right, well, g of 5 is the integral from 0 to 5 of f of t dt. So we want the area. We're going to start at 0, and we've got to go all the way to 5. So this is going to be equal to the triangle plus the semicircle. All right, there's our semicircle. Okay, so the area of the triangle, 1/2, times the base, which is 1, times the height, which is 3. The area of the semicircle, pi r squared over 2, but the radius is 2 units. So we have pi times 2 squared over 2. So this obviously becomes 3 over 2, or 1.5. And this becomes 2 squared, 4 pi over 2, so it becomes 2 pi. So we need 3/2 plus 2 pi, and there's 3/2 plus 2 pi.